Okay, we left off, we had just finished up working on the deck of cards, and now we are going to find out, well, if I look at a group of people, and they're just, one person is selected out of that group, what is the probability that they have a birthday in December? Well, the first thing I would want to do is just take, well, the 1 month out of 12 months, but that's not how it works because the months have different number of days, and so you need to get something more exact. So you want to use this information here, the fact that December has 31 days, and there are 365 days in a year. Okay, and yeah, we can talk about leap year and all that kind of stuff. Anyway, we're going to do it this way. Okay, so let's see if we find the probability of a birthday in December. We know that the number of possible outcomes is 365 days, and then 31 of those would give us the days in December. So if I do this, this becomes 0.084 or 8.4%. Now there's a note on rounding down here that I want you to read. You want to express a probability as an exact fraction or decimals, rounding the decimal to 3 significant digits. And what that means, that we would want 3 digits. Now I did this one as 2, but you can do 3. So look at that and see how rounding will occur. As we get to testing on that, I'll be specific about how to do that. All right, let's talk now about comparing relative frequency and theoretical possibilities. Remember, relative frequency is what happened. We did an experiment. Theoretical is what should happen. You can also think about this in terms of finite and infinite. What should happen, and this goes to the law of large numbers, as you do more and more and more trials, you should get closer and closer and closer to the theoretical possibilities. If we go back to that first page, you notice that several of the groups were way out of whack. We had 7 and 23. So when it should have been closer to 15, 15. And as we added them all up, it did get closer to that. So what happened is going to be based on data or an experiment or something of that nature, because you cannot do an infinite number of trials. Theoretical is if you could do an infinite number of trials, what the results would be. So you can think about this in terms of finite and infinite if that is helpful for you. Okay, so and that goes to the law of large number. So the relative frequency probability gets closer and closer and closer to the theoretical probability as the number of experiments or the amount of data gets larger and larger and larger. Okay, so what that means is the smaller the sample, the smaller the number of experiments. That means that your data can be way off. But as you do more and more, again, it should get closer and closer. Okay, so let's see. There are only 2 possible outcomes when you flip a coin. It's either heads or tails. So the probability for each is 50%. That just kind of makes sense. Okay, if we flip a single coin 4 times, would it be too surprising for the coin to land on heads 3 out of the 4 times? Well, you could argue this either way, a lot of different ways, and I would hope that you'd have some discussion on this, but I'm going to say no. Okay, because the experiment has only 4 trials. That is not a large number. So, you know, what can happen in the short term, and I will tell you, this is one of those things that really gets gamblers, is they know what the odds are, what the probability is. So they'll sit down and they'll say, okay, well, the next, I've lost money on 3 in a row, so the next one I have to, get a good hand. And that's not how it happens at all. Okay, now suppose you toss a coin 200 times and it lands on heads 105 times. Do you have reason to believe that the coins are unfair? Well, 200 times, you should get closer to, as you're doing more and more trials, you should get closer to 100 and 100 of each. So, no. I don't think it's unfair, because the theoretical probability of this is 50%. And then the relative frequency is 105 out of 200. And if I do the calculation on that, I have to get my calculator out, is 0.525, which is 52.5%. All right. These are close. Theoretical and relative frequency are very close. Okay, so now suppose you toss the coin 200 times and the coin lands on a heads 49 times. Do you have reason to suspect then? Well, I would say yes. Again, we know that the theoretical probability is 50%. The relative frequency is going to be 49 out of 200. Which is 0.245 or 24.5%. So I would say yes, it is unfair, because the probability, the theoretical and relative frequency are not close. Okay, now if you did this 200 times, if you did it 500 times, it should get closer to 50%. If you did it 5,000 times or 5 million times, every time it should get a little bit closer. All right, now we're going to talk to you about our third one, which is the subjective probability. Okay. And this uses experience or intuition. And again, this is one that can get us into all kinds of trouble. On this, the subjective is experience or intuition. I would say this is like a gut feeling. Okay. All right, so you just, let's see. This is the one that gets everybody into trouble in gambling. Okay, you just know you're going to roll a 7, or you just know this is going to happen, or you just know that sort of thing. There's no data, no anything to back it up. But it's just, or it's happened in the past. You know, last time I went outside without my umbrella, it rained. So this time it's going to do that as well. I just have that feeling that, based on experience, if I walk outside without my umbrella, it's going to rain. Whatever the situation is. Okay, so again, this is where gut feeling gets involved. So let's assume that you're rolling a single die, and we're going to identify the method. Okay, I am certain that you will roll a 4. I am certain. This becomes a subjective. There's no data to support it. The theoretical probability does not match. After 20 roll, the die lands on the number 4 a total of 5 times. According to this data, okay, so now we're looking at data on a finite number of trials, so this is going to be a relative frequency. And then our last one here is talking about what kind of probability of rolling a 4 is 1/6, because there are 6 possible numbers on which the die can land and only one number is 4. This is theoretical, because that's what should happen. Okay, so let's now move on to the next one, and let's talk about the probability of an event not occurring. Okay, so if we're talking about an event not occurring, all right, let's consider the rolling of a single fair 6-sided die, and this is going to go back to theoretical probability. What is the probability that you roll a 3? Okay, remember on a fair 6-sided die, 1, 2, 3, 4, 5, 6 are the possible outcomes. There is one way to roll a roll a 3. So the probability of rolling a 3 is 1/6. The probability of not rolling a 3, well, there are 1, 2, 3, 4, 5 ways of doing that. So let's see, if I add these up, if I have 1/6 plus 5/6, remember when we're adding fractions with the common denominator, we have 1 plus 5, that becomes 6/6, which is 1. Why do they add up to 1? Okay. Well, this goes back to being a certainty. So why do they add up to 1? Because the probability of a 3 and the probability of not a 3 is a certainty. It's either going to be a 3 or not a 3. So these two, so that means that the probability of the 3 plus the probability of not 3, a certainty has a probability of 1. So this leads us another way to come up with the probability of something not occurring. If you have the probability of A, then the probability of not A is just 1 minus the probability of A. And we could have done this. All right. The probability of getting a 3 is 1/6. So I could have done this as the probability of not a 3 would be 1 minus the probability of the 3, which is 1 minus 1/6, which is 5/6. Okay, so let's see what we've got here. If today's forecast predicts a 37% or a 0.37 chance of rain, what is the probability that it will not rain? Okay, so if it's going to not rain, so let's see here. So the probability of not rain is going to be equal to 1 minus the probability of rain, which gives me 1 minus 0.37, which is 0.63. Okay, is this a relative frequency, theoretical, or subjective? This is going to be a relative frequency. Because it is based on previous data. Anything dealing with the weather I kind of think is subjective too. Wouldn't that be a great job to have, is just to get paid for, you know, whether you're right or wrong? Okay, so referring to a standard deck of 52 playing cards, what is the probability that a single card selected at random is not an ace? Okay, so let's find the probability of not an ace. Well, that would be 1 minus the probability of an ace, which is 1 minus, and there were 4 out of 52. So let's remember here how to deal with fractions. We cannot add or subtract fractions unless we have a common denominator. So what I'm going to have to do is take a 1 and turn it into an equivalent fraction, which we've been doing before. So I know 1 can be written as anything divided by itself. So 52 over 52 minus 4 over 52 becomes 52 minus 4 is 48 over 52, which reduces to 12 over 13, and you could also convert it into a percent. Okay, is this relative frequency theoretical or subjective? Whoops, this is theoretical. I knew it was theoretical. I almost did the wrong thing. Okay. Why? Because there's no data. It's based on what should happen. Okay, based on her performance during a recent season, a player has an 80% chance of making a free throw. What is the probability that the player will not, or will miss a free throw? So the probability of not a free throw is 1 minus the probability of a free throw, which is 1 minus, and of course I have to remember to turn this into a decimal, 1 minus 0.80, which is 0.20, and since they gave it to me as a percent, that's 20%. And once again, this is going to be relative frequency because it is based on data from past performance. Okay, gonna switch again.